Hello everyone. Let's start to solve this problem that I have solved yesterday only. Yesterday's problem, medium one. But I felt this is a very easy and I have made a very easy solution. Let me share it with you all. So as you can see, we have to find longest increasing subsequence. Given an integer array nums, return the length of the longest strictly increasing subsequence. What does it mean? So make sure these words are pretty clear. Okay. Strictly increasing subsequence. That means 2, 3, 4, 5, 6. It is not even 2, 3, 4, 4, 5, 6. So it should always strictly increasing subsequence, and it is not even continuous subsequence. Okay. Don't feel like let's talk about more with this example. 10, 9, 2, 5, 3, 7, 1, 0, 1, 18. So let me copy this and let's so problem description is very simple and one line problem description. So let's take this up. Yeah, reset and let me put it over here. So first step, we have to take our notes. Even the problem description is very small. We have to take our points, what we have understood. So problem description points. Okay, let me change the font family. Yeah, this is better. So first thing, what we have given is an array. So let's add a given stuff, given array, nums array. Okay. Second, we have to, what we have to do, we have to return the length of longest strictly increasing subsequence. Okay. We have to return longest strictly increasing subsequence. So let's understand these words first because these words are playing a vital role in this problem. So yeah, so this example, let's understand. So if you just see this numbers array, we have a couple of numbers 10, 9, 2, 5, 3, 7, 1, 0, 1, 18. If you have to verbally find the longest strictly increasing subsequence, then it would be start from lowest number. We have to always start from the lowest number. Why? Because if you start from 10, then your next number should be 11. Yes or no? So it would be, so we have to first look 10, and then we got another small number 9, and then we again got another number 2. So we will most probably start from 2 because I guess 2 is a very uh, smallest number in this array. So 2 and then 5 from this range 5, and then again we got 3. So we have to replace 5 with the 3, and then 7, and then 101 also bigger than this, and we got 18. So 18 is bigger than this. So the longest strictly increasing subsequence will be 2, 3, 7, and then 18. As let's see here also. Oh, they are showing 2, 3, 7, 1, 0, 1. But yeah, that's the end of the array, right? So that's the reason. It doesn't matter. We can even pick the 2, 3, 7, 18 also. That will also come under longest strictly increasing subsequence only. Okay. But yeah, we have to do this. Okay. So let's understand, let's write our approach, like what we have to do. So this is something we have understood, and let's see the constraint, the most important one. So the numbers lengths are in the limited size, so we don't have to worry about much, and the numbers are also in the range of normal integer size, so it's fine. So let's add a constraint as like this. Okay. So this is what it is. Okay. So numbers length will be start from 1 and end with 2500, and numbers of y will be minus 10 raised to 4 to 10 raised to 4. Okay, cool. So that means here you have to understand our numbers can be in negative also. Okay, it is minus 10 raised to 4. Okay, so let's write our approach. So what we should do? Hmm, let me take this example here. So as the our loop start to iterate, I will just simply take the first number in my LTS. So I'm gonna make one data structure which will my LTS, and here I will in the start only I will push the first number of the array. So I can directly push the first number of the array since our number of numbers array will be start from it could even 1. Okay, so if it is start from 0, then it might be cause an issue. Why? Because if it is an empty array, then you cannot pick any element from it. That's right, you know. So that's the reason we can simply put the first number of this array into our LTS array. So we are maintaining only LTS array so that we can maintain the elements in it. Okay, strictly increasing subsequence. So first we have 10. So we will start from one index. Okay, why? Because we have already stored at first number in our array. So it is making sense to start from 9. Okay, so this is what we have now. And here we're gonna check the LTS array 10, this element. So we're gonna check 9, is it greater than 10? If yes, then replace it. So we got here 9. Why? Because 9 is the smallest number than 10. So that's the reason 9 has replaced the 10. So now we have LTS array like this in the first iteration. In the second iteration, we got 2. So again, we're gonna check with the 9. So 2 is again smaller than 9. So our LTS array will become 2. Making sense? Why we are replacing the elements? Because we want to have a smallest, we have to start from smallest number. Then only we will get the longest substring, right? Here we have to find longest. If we start from a bigger number, then we cannot find the longest substring, right? So that's the reason I'm storing the least smallest number in the first. Okay. So let's go with now 5. So 5 is smaller than 2? No. Here there is a check. Okay. So 5 is greater than 2. So we have to push the 5 into 2. Okay. So when we are pushing a new element in our LTS array, we have to make sure one thing to be true, that the incoming number should be greater than all the existing of elements in the LTS array. So since we have only one element, so we are only checking with the first element. So what we supposed to doing, we're gonna check the incoming element, whatever the incoming element from the iteration from the outer loop, and we're gonna make one more loop for our LTS array, so that we can check the incoming element should be greater than all of our existing element in the LTS array, so that we can push it out. Otherwise, we will simply replace like this. Okay. So now our LTS array becomes 2 comma 5. Okay. So now in the this iteration, one second. Yeah, excuse me for that. I got a call. So let's delete this. Why we have made this arrow? We have to pick this. So now this 3 will be checked in the this now 2 5. So now we have to iterate the array. We are already iterating this LTS array, but yeah, now we have to actually iterate this 2 comma 2 5 array for the 3. So we can make something like this. Okay. So here we are making one more loop. We are checking for the 3. Okay. So make sure I'm gonna add a 3 here. Why? Because 3 is my incoming element. So I have to take a decision here. Should I add it or should I replace any existing number? So 2 is bigger than 3. Okay, that's fine. In the first iteration, 2 is bigger than 3. That is fine. So we have to one step. We have to go to here and now here. Now 3 is smaller than 5. Okay. So once we find a smaller element, once we find a bigger element in our LTS array, we'll simply replace. That's it. So now our LTS, so here this 5 will become to 3. So now our new LTS array will be 2, comma 3. Okay, cool. As you can see, we have a only one step ahead, the second number. Okay. So now in this iteration, again we have to check in our LTS array. Now we have a 7. Yes, 7 in this array. Same, we have to loop through this LTS array with the 7. Check 7 is greater than 2. Yes. Then move the pointer. 3 is greater than 7. Yes. So we got a incoming number which is greater than all of our existing number. Okay. So when we are going to push the incoming new number into our LTS array, when we find the incoming array is bigger than all of our existing elements in the LTS array. So now here we're going to push it down. Making sense? I hope it is. So now here I'm gonna push it down this 7. Okay, so we got 237. So here I have 101. Okay. So again we have to now check. We have our 3 elements. Same, we have to iterate. In the first iteration, we got 101. Is it bigger? Let me write it down. 101 is bigger than 2. Yes. Then move. Check. 101 is bigger than 3. Yes. Then move. 101 is bigger than 7. Yes. So my incoming number is bigger than all of our existing numbers. So what we have to do? We have to push it. So here we have to push 101. Okay. So now we have a last element 18. So we have to check for this element too. And same, we have to iterate now. So check 18 is bigger than 2. Yes. So move it down. 83, 18 is bigger than 18. Yes. Move. 18 is bigger than 7. Yes. Move. Now here 101 is not bigger than 18. Sorry, my bad. 18 is not bigger than 101. So now what we have to do when we find any our existing element in the array which is not um, smaller than the incoming element, so we have to simply replace. Okay. So I guess this resultant array should be like this only. I don't know why they have written like that, but yeah, it is fine enough. We can go with our approach. Okay. Simple. When we have to push our new element, when our incoming number is greater than all of our existing number, at that time we will push the new number. And when we have to replace the incoming number with the existing element number of our LTS array, when we find our incoming array, incoming number is lesser than the existing element of the LTS array. So here you can see 18 is lesser than 101. So we simply return it out. So this is our final LTS array that we can simply return the count. That's it. I hope this is making sense. So let's code it. Okay. Uh, Let me take a link from here. Yes. Longest increasing subsequence. Cool. So what we have to do is, again, we're gonna use our approach diagram lot while coding. Like I said, this will gonna definitely help you. So we have to first create our one LTS array, and then we're gonna add first element of the number, right? Tens, like I said. So we simply write it down, nums of 0. It completely makes sense as per the constraint. Okay, you don't have to worry about the edge cases. Why? Because our number will have at least one element in the array. Okay. So once we have written, so what we have to do, we have to make a for loop. Let I, again, we're not gonna start from 0. Let's come back to diagram. You can see, we are starting from first element. So 1. Why first element? Because we have already stored the first element of the numbers array in our LTS. That's the reason we are starting from the second index. That is 1. And here nums I less than nums dot length I plus plus. So we have created a loop. That's correct. We have to start from 1, go till end of the loop. That's fine. And once, like I said, when we have to push a new incoming number to our LTS array, when we found that the incoming array is bigger than all of our existing elements of the LTS array. So we need to maintain a flag, right, for that, so that we can do at the end of the loop. So here we'll write one flag. We create one flag. Is number bigger than all? Initially it will be false. Okay, so here we're gonna create our nested loop for our LTS array. So LTS array also an array, right? So we need to loop through the LTS array also. So let j equals to, so here we have to start from 0, not from 1, because we have to check each element of our LTS array for the incoming element. So j less than LTS dot length, semicolon, j plus plus, and here we have to simply check if my incoming number, which is nums of I, is greater than our existing number of our element, that is LTF of j. If it is there, then what we have to do, we have to make this flag as true. Okay, this is one check that we have to make for sure. Okay, and second condition what we have to make, if our incoming number is lesser than in our LTS array, so we have to replace that also, right? If you just see here 2 comma 5, so 3 is the smallest number than our existing number of our LTS, so we have to replace the 3 with the 5. Yes or no? So that we can make a proper longer strictly increasing subsequence. So let's go. So we have to add a condition for that too. Else if my number, incoming number, is lesser than our LTS of j, then what we have to do, we have to is number. First, we have to make this flag as false. Why? Because we are gonna add the element at the end of the loop, right? If this bigger than all is true, yes or no? So here we have to make first this as false. Why? Because if or any one of the number is bigger than our existing element and the second number, so here also take an example. So 3 is a bigger than 2. So our flag will be true, correct? So here it went to lesser than. So here we need to replace, right? At the end of the loop, we are gonna check this all as well, correct? Is number bigger than all, it is still as true, then we have to push the new incoming number to our LTS array, correct? So for that reason, we have to make this flag as false when it's encounter into the second condition. Okay. LTS push the incoming number. Making sense? So that's the reason this check. Okay. So here we have to replace, right? So if you don't make this false, what will happen? It will replace and it will even add. Why? Because number bigger than all is true. For the first element, it is true. For the second, we have replaced, and in the last, after this loop, we are adding as well, right? So when it come to this line, our is number bigger than all is true for the reason for because of this two element. Yes or no? So that's the reason we have to make this is number bigger than all flag as false so that it will not make any problem after the loop. So here we have to replace. So what is replace? Simple. Let LTS of j, which number is lesser, bigger than the incoming array, any bigger than incoming number, LTS of j equal nums of I. Simple. Okay. So this is one thing that we have to make for sure. And second, one thing that we have to that we haven't got because of this number. I'll pick one more test case. Maybe here. Yeah, this would be the proper test case, I guess. Yeah. So let's bring it out on our diagram. If I got any same number, like here, there are all the numbers are different. So what will happen when I got a couple of numbers are same? So that time it will make a problem. Why? Because let's see this problem. So let our LTS array will be have 7, and in the second iteration, 7 is neither less than nor bigger than. So it will never be in any condition. Okay. So it will unnecessary check all of this thing. Okay. So this loop will be work for all this thing, all the incoming number. Simply, if the new number, incoming number, if it is already present in our LTS, so why do we have to check for all the other number? Yes or no? Because it is already there, it is position, right? So if we got any new incoming number which is already present in our LTS array, so we have to break the our J loop. Unnecessary, right? Unnecessary, right? So we have to make one check for that too. If nums of I is equivalent to LTS of J, so that we have to make this loop terminate just to improve our runtime. Yes or no? So break the loop and don't forget to make the flag also false. So what again I am repeating the same condition. If one of the number is bigger, then it will be turned to true, and the second number is same, it will font same, and then it will break only. And in the after breaking the loop, we are checking is number is bigger than all, push it out. So that make again problem. Same like this for this. So make sure make the flag false. Okay. This is important, guys. So that's it. We have done our code easily with the help of our approach. So let's give it a try. So we have to what we have to return LTS of length. That's it. Because we have to return a count, not the array. So let's make a cross finger. No, why do we have to make a cross finger when we are very sure about our approach? So let's run the code. 1, 2, 3, 4, 5. Ta-da! We got successful. And now let's submit the code. 1, 2, 3, 4, 5. Oh, there is a problem. Okay, fine. Not an issue. So what is a there is a typo here happen. So here you can see is number bigger than all is incorrect. My bad. So yeah, and now it's correct. Let's give it a try again. So the problem is because of the same number. Like I said, the 4 is repeating. Okay, it is break, but the is number bigger than all is oh sorry. Here also we have to make false. My bad again because we have to make it false. Okay, so now let's give it a try again. 1, 2, 3, 4, 5. Oops, again. My bad. Let's see what we are doing wrong. Mm, okay, again, we have to forget to break the condition. Okay, since we found the number is smaller, the incoming number smaller than the existing element, a number of LTS array, we have to break the loop. Don't forget to break the loop. This will give a problem. So let's do it. Now in this time it should work. Let's see. Ta-da! Cool. We got 86.85% of user with the JavaScript and 99.11 guys. This is the top. When I ran this code for the first time, it didn't give this much, but yeah, now it is given. That is cool. I hope you guys understood this problem and explanation. Let me know anything if you want to say in the comment section. Thank you all and see you in the next challenge. Bye bye. Take care.